welcome to this week's math lesson. Go ahead and please take out your math notebooks, turn to a clean sheet please, name and today's date. Your topic or your objective today is I could solve percent applications using simple interest. So previously we've been talking about percentages and converting and going back and forth and finding wholes, parts, percents, but now we're going to be using all of that in real world application problems. And how best to do that is talk about simple interest. In life, as you get older, you either now or in the future will have a bank account. And in the future, you will have a credit card, and you will in the future be buying your own home or buying property or buying something that requires either interest or will accumulate interest. Interest is when in a value, like for example, when you put money into the bank and you have it for a long period of time, you accumulate interest or extra money. Similarly, if you have a credit card and you have money on that credit card, your interest will accumulate for how much money you have, and you'll get charged having that amount on that card per month. What's nice though is that we in math can solve that using this formula. So in your notes, I want you to copy down this formula. I equals P times R times T. And I've broken down P, R, and T into three different amounts. P is your principal amount, or your starting amount. R is your rate. And again, a rate is often in a percentage. And again, we'll talk about this down below, but just for right now, copy down that the rate is a percent. And T is known as your time, or the time in years. We always make sure we go by years when looking at interest. So, let's say for example, we start off with having a bank account that has $1,000 in it. Start off really, really high. And let's say that our bank charges 5% interest. And let's say that we keep this money in the bank for 5 years. And we want to figure out what is the interest for this amount of money with a 5% interest rate for 5 years. So all we do is multiply our principal times our rate times our time, but we have to set it up in a certain way. So if we look here, if we do 1,000 times, now 5%, because that's our rate, we have to turn percentages into what class? Decimals, that's correct. So 5% becomes 0.05. And then we're going to also multiply that by 5 years. So, if we plug that into our calculators, and we took 1,000 and we multiplied it by 0.05 times 5, we would end up with an interest in 5 years of $250. Now, as I've taught this before to 7th graders, many 7th graders go, Mr. Campbell, that's not a lot of money. Well, if you think about it though, in 5 years, they're paying you to have that money in the bank account. That's $250. You don't have to do anything. They just pay you that money. So, let's look at another problem, shall we? Now, let's say we have a credit card. And let's say on that credit card, we have charged $500. We bought some clothes, CDs, video games, and we got about $500 on that credit card. And our interest rate on that credit card is 12.5%. You're going to see where I'm going with this. And let's say it takes us, say we hold on to that $500 on there for, we've done 5 years last time. Let's do 6 years. Now, if we hold on to that $500 on that credit card for 6 years, let's figure out how much interest is going to be accumulated on top of what we already have to pay. So first things first, we multiply 500 times 12.5% would become, if we were to change to a decimal, 0.125. And we're going to multiply that by 6 years. So if we go ahead and multiply that, we end up with an accumulation of $375. Now, what does that mean? That means when we have $500, we're going to already charge on that credit card. We also have to add that interest back in. So now, and again, this is why when you're having credit cards, people want to pay them off so fast, is that if we keep money on there and we don't pay anything on it, or we pay the minimum, in 5 years, your $500 that you just charged for your video games, CDs, and likewise, becomes $875 that you now have to pay, which is a lot of money. Let's do one more. Let's say we buy, okay, let's buy a house. And let's say we pay $90,000 for it. It's a really nice house. 3 bedroom, 2 baths, really nice. And our interest rate on this payment that we have to pay, let's say it's 10.5%, really high. And we have, in the course of 20 years, have to pay it off. What would be the interest on this $90,000? Let's go ahead and calculate that, shall we? So once again, 10.5%, we have to change to a decimal. So we get now instead, moving the decimal place over twice, 0.105 times 20, because our units are in years. So 90,000 times 0.105 times 20 is how much? So in the course of paying this off with a really high interest rate, our interest would actually be $189,000, and added to our $90,000 that we paid for the house. So this is why sometimes maybe your parents get a little frustrated with how much they're paying because of interest rates. That our grand total for the house, really, adding interest rates, would actually be $279,000, which is a lot of money. Let's go ahead and do our exit slip now. So, leaving this formula up, go ahead and complete the following. What I want you to do is I want you to find the interest given that you have a bank account that has $750 in it at a 1.2 interest rate, and you're keeping it in there for 7 years. I'll give you a minute to go ahead and pause the video to answer the following question. All right, let's go ahead and solve this, shall we? Once again, 750, I equals P times R times T. We're going to multiply 750 times our rate. So again, we have to change this to a decimal. So 1.2% really becomes 0.012 times 7, because our rate is in years. So 750 times 0.012 times 7. So, in the course of 7 years at a 1.2 interest rate, you would accumulate an extra $63. Your homework is posted in Google Classroom, where you're going to be answering similar questions like this, revolving around principal rate, principal amount, rate, and time. Join me next time. We'll be delving into using the same formula, but instead, we're going to be looking at converting when we're dealing with months of time instead of years in time. Stay tuned, 7th grade, and keep studying.